In how many ways can you arrange m distinct objects? Say you have the distinct letters A, B, C, D. Now the first position can be filled up in 4 ways. And once you have made that selection, you are left with 3 letters, any of which can go into the second position. That means each of the first rows is multiplied 3 times and you're left with 12 rows. Now for each of these 12 rows, you have 2 letters left, either of which can be put into the third position. Which means that these 12 rows multiply into 2 for each row, and you're left with 24 rows. And of course, the last position letter is automatically fixed. You're left with only 1 letter. This means that 4 letters can be arranged in 4 into 3 into 2 into 1 ways, which is also known as factorial 4, denoted by 4 followed by an exclamation mark. In the general case, m objects can be arranged in factorial m ways. Now the next question is, in how many ways can you arrange n things taken from m things? N is of course less than m. Since you are taking a subset, we marks spots from 1 to n. Now we have m options for filling up the first position, m minus 1 for the second, since we have already taken 1 for the first position, and so on, until you reach the nth position and you are left with m minus n plus 1 objects to choose from. So if you recall the previous logic, the total number of ways of arranging n things taken from m things is equal to m into m minus 1 into m minus 2 and so on until up to m minus n plus 1. Now let us multiply this expression with this fraction. The numerator is equal to the denominator, as you can see. And after this, in the numerator, you have the numbers from 1 to m all multiplied together. And in the denominator, you have the numbers 1 to m minus n all multiplied together, which is basically factorial m upon m minus n factorial. And this is the symbol for this expression. MPN is a symbol for it. The second question is, in how many ways can you select n things from m things? The order in which you select doesn't matter, only the elements of the selection matter. So this is different from an arrangement. Okay. So as an intermediate step, let us first arrange n things taken from m things. This you already know to be factorial m upon m minus n factorial. Now in these factorial m upon m minus n factorial arrangements, there are many arrangements which belong to a common set of elements, just arranged differently, like say ABCD and ACBD, both of which have the same set of letters. Now you know from your previous slides that n distinct objects can be arranged in factorial n ways. This means that factorial n of such arrangements in the total group of factorial m upon m minus n factorial arrangements actually represent only one selection arranged differently. So if we just divide by factorial n, we'll get factorial m upon factorial m minus n into n factorial as the number of ways in which n things can be selected from m things. The symbol for this expression is one of these two, both of which you'll find in mathematical texts.